you bend it too much. Hi, good morning, everyone. I mean, good afternoon. It is the Detnet working group session. It's time to get started. Yeah. So what you see on the screen is the chair's intro slide deck. The online agenda and the slides are available via this link. And this is the page for the working group. We follow the IETF note well. If you are not familiar with it, then please go and study. It is available at various places on the IETF webpage and in your app for the IETF agenda and so on. So we follow the IETF rules. There is audio streaming and recording. Please take this into account. Please make your comments to the mic, and please say your name first when going to the mic. We are having the usual joint minute taking on the Etherpad, so please contribute to the minute taking. That's really helpful for the working group and to our secretary Ethan. The Jabber, this is a Jabber link. Lou is there on the Jabber, but it would be great if someone else could join as well. As I mentioned, the online agenda and the slides are available via these links. And please fill in the sheets. Actually, they turn to be white. They are not blue at this meeting. Maybe too much washing. But anyway, those are the blue sheets. Please fill them in. Don't bet too much with the color. We turned out to have a quite busy agenda. So please, presenters, please try to keep to the time allocated. And actually, we have some overtime requests. The agenda is, or actually the, maybe it's, no, let's go back. So when we request the time slot or the session time, that is based on the email list discussion. And when we did the request, we did not expect this many contributions. So please be active in the email list as well, but I will come back to that in a minute. Before starting the Detnet discussions, just to mention that there is a joint workshop between the Detnet working group and the IEEE 802.1 TSN task group this Sunday from 8 a.m. In this hotel, actually exactly in this room. The agenda is available here. So this is the link during the meeting for the agenda, and we are high with the separate place. So this will be the permanent link after the meeting. This workshop is practically hosted by 802. So we will follow the IEEE 802 processes. And the minutes will be available. They are public. They will be available for the Detnet working group. Unfortunately, remote participation is not possible. More on the administrative details when on Sunday. This is the agenda for this joint workshop. Just one sentence, maybe on the agenda, that when we crafted the agenda, our main goal was to have items that requires discussion, and both groups would benefit discussion and interaction items between the two groups. So that was the main driving line behind the agenda. The mailing list, as I mentioned already, the mailing list is very important to our work, the work of the working group. The consensus is determined based on the mailing list, and we use the mailing list for decision making, resolving issues, and so on. So please be active on the list, and even for our slot request, we use the mailing list. IPR, we follow the process put in place for the IETF. We have IPR call before adoption and working group last call. So you'll see those emails in the working group list. and we may ask directly the authors if they don't respond, or contributors. Status of the working group. We have 3 drafts that is with the IESG. The Detnet use cases is the one that is most far ahead. That was discussed at the last IESG call. So we are getting done with this. The next one is the problem statement, which is also getting ready. And as for the architecture, there are a few, like 4 outstanding comments still to be resolved in the email list. You will see email on that shortly. So that's at ISG review as well, and then it will, after resolving those comments, and there will be one more revision of the draft at least. It will be scheduled on a call as well. From the working group drafts, what we have on the agenda today is the 2 data plane solution documents, the flow information model and the Yang data model. One of the working group drafts is not on the agenda. It is the security draft. There was an update. It was distributed on the list. Comments are welcome, but actually it is gated at the moment by the solution drafts. And just taking a double check on our deliverables and milestones. So this is the deliverable list, core deliverables. So we have the architecture document, IETF last call as we discussed. Data plane is progressing. You will see an update soon. And flow information model, we still have some work to do. And the Yang data model draft just got adopted by the working group. We have a working group document now. This is the newest document. And we now need to work on it as a working group document. Would you like to add anything? Okay, then with that.
Actually, now that I think of it, I'm going to show the Etherpad link in the hopes that others will join and help us out, take additional minutes. So that's the Etherpad link. Right now we have myself and Ethan there. Please join go to that URL and add notes. It's particularly important if you make a comment at the mic to confirm that your name is appropriately captured and that your comment is appropriately reflected.
Okay, first presentation is from Balázs on the data plane solutions.
Yes, so I will give you an update on the data plane documents. We have, I think, quite good progress on these documents. Oops. Okay. So this will be a common presentation for both the IP data plane and also to the MPLS data plane. But I will show you during this summary what were the updates in the new version. We are at 0.1 version for both documents. Also listing what further work is still needed on the documents. And then at the end, we can discuss also some next steps regarding the documents. So let's start with the IP data plane document. There were some editorial work. So we had a structure cleanup on chapter 3 and 4. They are now focusing on overview and scenarios and the Detnet IP data plane consideration. I will not go into details. We have also slides about the editorial changes, but I would more focus on the new content, what we have added to the document. And it is about the IP data plane procedures, which containing the conformance language for the data plane procedures. And we have also a chapter 7, which is dealing how to map Detnet flows to and from TSN domains. So this is the scenario where 2 Detnet nodes are interconnected by a TSN subnetwork. So chapter 3, editorial changes, I will skip this slide, like the next one, which is also showing the chapter 4 related changes. So let's focus on the procedures. This is a new chapter in that sense that this is the first time we have the text in this chapter in detail. There were many discussions in the recent months in order to fix the content of this. So what we have now in the document, this is practically the summary and the result of those discussions that we had before the meetings. So it is showing how flows are identified. It is covering both IPv4 and IPv6. There is also a section forwarding procedures, which is focusing on the standard IP forwarding next hop selection, how it is impacted by Detnet. And we have also traffic treatment procedures related section, which is dealing how Detnet node must provide Detnet QoS. And there are also some aggregation related consideration included in that chapter. So let's go to the details on each of this. First of all, for the flow identification, we can create an ordered list from the fields that can be used for the flow identification. And it is a must requirement that flow information matching is based on the first match in this ordered list. In order to support aggregation, you can use mask lists and wildcards when flow identification is defined. It is also important to highlight that in a node, within a node, you will have states about both aggregates and component flows. However, there might be some nodes or some scenarios where one node is just taking care about the aggregate flows and the next hop will taking care about each of the Detnet flows. So let's look to the IP header fields, which we intend to use for Detnet flow identification. Now in the figure, you will see the IPv4 fields, but of course, the document defines also for IPv6 the fields. So there is a must requirement on the source and destination address, and we have a should requirement regarding to support the longest prefix match. The next field, which is important, is the IPv4 protocol field or IPv6 next header field. This is pointing to the next layer protocol. Here we have must statement regarding some values. We will have a dedicated slide coming soon on that. And we have a should statement regarding other values can be also used, or this field can be ignored during the flow identification. We have also included in this sixth tuple the DSCP field. And here we have a must statement regarding to include that. And of course, we have should statement regarding that you can list multiple values, but please do not mix the Detnet DSCP with non-Detnet DSCP on the same 5-tuple flow. As you can see also here on the top of the figure that ECN is excluded from that field. So Detnet sources do not care about ECN, so they will not throttle back themselves if there is congestion in the network. They are expecting to have the service from the network. So this is why ECN is, it does not matter in case of Detnet flows. Flow label, this is also something that was not discussed for the simplified IP encapsulation. But now we have in the document with should statement the IPv6 flow label. So in case of IPv6, that gives you the possibility that with the source and destination address plus the flow label, you are able to identify the flows. This is a should statement. And here I will stop just for a moment to ask the people in the room what is their view regarding any comments or objection using this flow label.
This is an opportunity for David Black to say we're doing something wrong, by the way. And he's declining, so we appreciate that. Thank you.
Please use the mic. We have some remote guys.
David Black, Transport Tech Advisor to the working group. So one of the chairs invited me to make snide remarks about this. I declined the invitation, but said I would split hairs on 5-tuple versus 6-tuple and their uses later.
Okay.
Yeah, I suppose we should put in the record. I spoke to some IPv6 experts on this a couple of days ago. So within a domain, you can trust the flow label. So that is to say,
I'm sorry, within a domain you can trust that
you can trust the flow label.
Right.
All right. The thing about it though is that you have to have control of all the routers in the domain, because what they do with it is a configurable option on the router. So we should probably put some text in around this. But basically, we can use the flow label as a shortcut, providing we can make sure that all the routers on the path are obeying our rules about its use, not using it for something themselves, and that there are no other stray packets going to get in that are also going to mimic the behavior we want.
I look forward to the pull request that contains that comment in the management consideration section.
I will give you some text.
That'd be awesome. Thank you.
Okay.
David Black, and what Stuart just mentioned has also been raised as an IETF last call issue on the architecture draft, namely that you need to protect the edges of the domain, both to prevent stuff that doesn't look right from getting in and to protect failures, misconfiguration, etc., from allowing non-elastic Detnet traffic out. What do you want to do? What do you want to do about that, chairs?
Yeah, that's actually a good point. I was actually writing the response to that in my email right here. One of the things that you just said was a very key comment, a key caveat in that comment, is that it's for non-elastic. It applies to non-elastic traffic, and Detnet is actually not at the transport layer, and we're not specifying what behaviors are at the transport layer, and so the comment about elasticity applies to the transport protocol, not to the Detnet layer. And
right. My concern here is that, as I understand how a Detnet QoS chunk of a router sends traffic, I believe that that traffic behavior looked at just by itself, without starting with transport, namely if you fill all the slots, is inelastic, and therefore we have to take, in order to protect the rest of the world against Detnet, we have to start from the baseline assumption that we've got inelastic traffic.
I don't understand that statement, but if there's someone who wants to come to the mic, assuming they're responding to you.
Yeah, no,
Name, please.
Stuart. I think the important point is that we take a relatively I suppose slack or a more relaxed approach to what gets into an IP network normally, because it's very difficult to protect every single edge compared to an MPLS network where you only get into the network and be allowed to be free. Well, you're never allowed to be free. You're just into the network. You'll put an MPLS label goes on, and you do what that label says all the way through. IP has traditionally found it much harder to do this because of the number of edges and exposed sort of attack surfaces, I suppose you might call them in this context. And we're going to have to really up our game in terms of IP in order to build an IP deterministic network.
The comments that are coming in on the architecture document are basically implying that Detnet is a tunneling technology. It really isn't. Detnet is a transport. We're still transporting, sorry, overloading the term transport. I don't know.
You mean transport network, or do you mean
it's a
transport?
it's an IP transport network, right? And because it is an IP transport network, it is operating below the normal transport protocols, and it doesn't impact those transport protocols. All it does is impact the congestion experienced or the traffic treatment received by those transport protocols. So circuit breaker behavior belongs on a tunnel. It doesn't belong on an IP transport network. and that the transport protocol is still expected to do the right thing. And also needs to be if that transport protocol is modified to do something different than our normal congestion control behavior, it needs that circuit breaker behavior, not DetNet. So I'll put that in mail, and I think we'll maybe have a little bit of an argument.
Yeah, so the thing about a transport network,
IP transport?
a transport network in general, the general concept of a transport network is that things come in and they are put into the encapsulation that the transport network has, and they don't get to do their own thing. They only get to do what the transport network allows them to do. That's not a normal sort of IP design. IP, you normally, once you're an IP packet in the network, you do whatever the outer address says.
Right, but we don't impose transport, and I mean not transport network, but transport behavior, transport up here, behavior, because we're running on a transport network down here, and the comments being made are, do that. And I said, so I think there's some confusion by the folks making the comment that DetNet is not a tunneling technology.
I think
It's
the
a
best thing.
transport
I think the best
transport
thing to do. This is David again. I think the best thing to do is for me to read your response and then figure out what to do about it, because I don't know that circuit breakers are what are needed. On the other hand, it seems like a really good idea that the DetNet flow tries to escape from the DetNet network. It ought to get big bucketed at the edge as opposed to let loose on the wild world and have fun.
We do that in an IP network. So if you have an uncongested IP network connected to a congested IP network, the flows that come from the uncongested network will be let loose, as you just paraphrased, on that congested network. That's all we're doing with DetNet is we're assuring that for that traffic, it doesn't perceive that congestion.
I think this needs to go to email.
Great.
Okay, thank you. So let's continue on the email list.
Sorry about that. I know that it really hurts your time.
No. It is. I think we are still in time. Okay, let's continue on the fields that are defined for the protocol or next header. So for the mast, we have TCP, UDP, and the IPsec, and we can have should requirements on other formats. This is not yet specified in the document, so this is also something where you can, on the email list, comment to. For TCP and UDP, source and destination ports are ignored. This is a must requirement, and should requirement is to have some range-based port matching. For the IPsec, we have must requirement on the SPI field, and the should is to ignore this field completely. So this is about the flow identification and the conformance language.
Okay, this is David again with the promised hair split on 5-tuple versus 6-tuple. 80% of what I'm about to say is I will read the latest draft and try to write some carefully crafted text, because I think what's described here is what the implementation has to do. However, flow identification could lead to people making some incorrect inferences about a 4-letter F word. No, not that one, flow. And so I need to write some carefully crafted text, the upshot of which is that we, at the outermost layer of thinking about this, a flow is defined by a 5-tuple. A DetNet node has to use a 6-tuple to pick off the traffic that gets DetNet treatment, but that doesn't make that 6-tuple and a flow in a full generality. And I will try to edit some very careful text to keep us out of the tar pit.
David, that would be great. The text you probably want to write will modify the next version, because this current version has the issues that we've talked about on the list a little bit. So you'll probably want to do that based on the revised version.
That's fine.
That's not there yet. The other thing that you may want to pick at is that there's text in there that, then it's in here somewhere, that said that DetNet flow identification impacts next hop selection. And I think what you're really getting at is we want to do next hop selection based on the 5 tuple and traffic treatment based on the 6.
Yes.
And that's really the crux of your comment. And I think that's an accurate statement of an accurate observation of a failing in the current text.
Yes, and that's also the rationale for the should not mix DetNet and non-DetNet DSCPs on the same 5 tuple.
Yeah.
Okay. So let's jump to the other new content, which is about how to map to and from TSN. And here you can see on the slide the scenario where 2 DetNet nodes are interconnected by the TSN subnetwork. And in that case, these IP nodes can be IP DetNet end system, IP end system, or IP DetNet edge or relay nodes. And the concept is practically based on the TSN stream mapping functionality that is defined in 802.1 CD, where we have active stream identification function, which is able to catch the IP fields that we have discussed in the previous part of my presentation. So here there are, from scenario perspective, 2 options, 2 scenarios when the DetNet nodes do not have any TSN functions. So this is out of scope. In that case, the TSN domain have to solve this mapping and do the active stream identification function and ensure the proper VLAN tag and destination MAC address. We will focus on the other scenario, which is more interesting for the DetNet group, where the DetNet nodes are TSN aware. And this scenario can be modeled like we have a TSN unaware talker or listener and a TSN bridge relay within the TSN, within the DetNet node. And in that case, here are listed as a must requirement for the TSN component, but should be implemented on that DetNet node. And it is for recognizing the flows. There can be frame replication and elimination for redundancy functions inside the TSN domain. For that, you need sequence numbering, so there are functions related to the sequence numbers. And if that node is also participating, like a replication or eliminator point in the TSN domain, then additional functions are also needed. So just to wrap up, because I think we have 4 more minutes, is in the IP document, these are the chapters where we need some further work in order to complete the document. So OEM, management and control plane related consideration. In the data plane, also there were comments during this presentation, so this is something where we need some update. And on mapping to and from the TSN, we also need a conformance language, so describing the procedures and management and control implications. And there is also a need for a general editorial cleanup in the document. So this is how we are seeing the future for this document. Okay, and again, just a question. So we have not touched SRv6 in the document. So maybe this is something that is for a dedicated document in the future. Okay, just a very short summary on the MPLS DetNet document. That was in a much better shape before, so we have mainly focused on the IP document since the last meeting. So there the new content, we have also several editorial changes. They are just editorial changes. The new content we have here again regarding how to map to and from a TSN domain. Here the major challenge is that this active stream identification function is not able to recognize MPLS flows. So that means that if between 2 MPLS DetNet nodes you have a TSN subnetwork, you have to support TSN functions. So that node must be a TSN aware talker or listener from the TSN domain perspective. And here again, we have just listed what functions are needed. Here, of course, for the stream identification and the sequence numbering, this is something that must be MPLS flow aware in order to behave like a TSN aware talker or listener towards the TSN domain. Here we also have some chapters where we need some further work, management and control plane consideration related stuff. We need for the procedures, for conformance language, for the MPLS data plane operation, Detnet IP operation over Detnet MPLS service, and how to interconnect 802.1 TSN domains over the Detnet MPLS service. And again, a general editorial cleanup. So this is where we are. Contributions are also, as usual, always welcome. So we have, I think, quite a good plan what to update in the documents. That's it. Questions, comments?
Thank you.
Okay, this is an update on the flow information model draft. The current draft is version 2. It's a working group document, and currently it is a standard track document. There's a plan to change it to informational instead. So in this presentation, I summarize the changes that happened from version 1 to version 2, and list a couple of further items that require some further work in order to move this document forward. I need to highlight, as we are hearing, that the good news that the architecture is getting finalized, and the MPLS and the IP data plane solution documents are very stable now. So we have a good basis for the further work, like the flow information model, to which these documents are the basis. I'm glad for the email discussion we had on the flow information model in the list. I have thrown in some ideas for the update, and actually this update from version 1 to version 2 tried to capture these discussions on the list. So the main topics on the list were around what is section 2.5 in this document. That's the service parameters, and there was discussion on the delay parameters, and quite some discussion on the misordering, which is a bit of a new aspect here. So the changes really tried to capture these discussions as a contribution to the group for further work. A summary of the changes to this section 5.2, service parameters. The introductory text has been changed to bring it in line and up to date in light of the updates in the architecture. There was some restructuring in the section, like it was a bullet list plus some description. Now the description moved under the bullets to describe the parameters actually right there. There was no change to two of the parameters, the connectivity type and the service rank. It's exactly the same text as in version 1, just relocated. And there were changes to 4 of the parameters, the bandwidth, the delay, the loss, and the misordering parameters. I explain in detail one by one in the following slides. So it was made clear that the bandwidth parameter means the bandwidth guaranteed for the Detnet service. So these are what we expect to provide the Detnet service for our cyclic CBR flows, which require guaranteed bandwidth. The delay parameters, as discussed on the list, we need 2 delay parameters. One of them is the maximum latency, end-to-end one-way latency between the edges of the Detnet network. That what has been verified. Maybe further updates are needed for further verification. And the second one is the packet delay variation, which is the difference between the minimum and the maximum delay. That was kind of the consensus on the list, and that's captured in the document. As for the loss parameters, In this update, it makes it clear. There was some text around it in the previous version. It has been just clarified that we intend to have two kinds of loss parameters. The classic packet loss ratio, again, for the Detnet service between the edges of the network, and applications like control loop in a factory automation typically have a special loss parameter like maximum consecutive loss tolerance, which explains how many packets can be lost out of consecutive cycles of a periodic CBR flow. That would be the second parameter. And the maximum allowed misordering. Again, we are talking about service parameters. So this parameter would describe what is tolerable. I mean, how many number of packets are tolerated to be received out of order by the application. And this can be measured on the sequence number we have for pre-off. And formerly it was a binary value. Now it's an extension to the number of packets allowed to be received out of order. And the value 0 means that in-order delivery is required. Misordering cannot be tolerated. As I mentioned, this is service parameter, so kind of what is required from the Detnet network to provide towards the application. And if the network cannot provide it for whatever reason, then reports that the service cannot be established. This is the last slide. It's a collection of to-do lists. So of course, what I described previously, that's new text. We can further improve. So please comment if you see need for improvement. There can be further updates on the service parameters. That's what I was talking about and put here first. So this list, this sub-bullet list, the 3 sub-bullets are based on discussions this week. We may consider enriching the service parameters based on the flow information parameters, like adding traffic specification, the cycle, and so on to the service parameter as well. And the next 2 are up for discussion, whether or not the service is bidirectional or is it just unidirectional. What's the preference by the group for a Detnet service? That's one of the questions. And the other one was raised is whether or not the group wants to have a time-based Detnet service establishment and tear down, so that there was a lifetime of a service. So that's up for discussion. I'm afraid the second one would bring a bit of complexity and may delay our getting done, but let's discuss these items. That's why they are listed. We need to double check a number of items, given that now architecture and data plane are stabilized, like the flow-related parameters based on these base documents. We also need to double check in this document what is the text related to the Detnet domain and system and UNI. There's a number of sections I listed here that build upon these concepts that are described in detail in the architecture. And we need to pay attention and double check the consistency between the information model, which is this document, and the Yang data model, which we will hear about shortly. There are 3 sections that are just placeholders. We need to think about either fill it in or remove if we see no need for them. And the summary, INA, and the security consideration sections are pretty empty as well. And this is a working group document, so contributions are really welcome to progress with this document. That's I thought to say. Questions, comments?
Brian from Huawei. Just an idea comment. Do you think it is valuable to put the duration of a flow or service in the parameters? Because in some cases there might be for example, flow may have a expected duration of the total time.
Yes, so this is, you are touching upon the, do I have a, so the third sub-bullet is exactly what you are, yeah. So that's what, that's
Okay.
a discussion item. So
Okay.
it's, I would like to hear the view, opinion of people from the group.
Yeah, I think it is valuable.
So it's, I think we need to decide whether we want to include such a parameter or not.
Thank you.
We're actually getting into parameters that'll impact the control plane and the scheduling of resources outside of the data plane. You know, we have packet scheduling, but this isn't packet scheduling. This is scheduling of when a service will show up and when a service will go away. And that's to some degree, that's also the same thing with bidirectional service. We're getting into something that happens at the control plane level to coordinate traffic in both directions. In terms of the actual data plane forwarding, when you get to the hardware, you have to provision both paths in each direction separately. So it's more of a control plane concept. Of course, it does mean if we have a bidirectional service that it complicates mapping to the from layer 3 to layer 2, or at least has implications.
John Messenger. It could be a control plane parameter, tear up and tear down, or it could be considered to be to do with ordering. And if you look at the LSO reference model, there would be places where it might make sense to represent that kind of information too at a service establishment and ordering level. But if it was real time in terms of short-lived flows, then it might be more appropriate to put it in the control plane.
Let's get you there. At some point, we had also the idea that in the UNI that might be useful for the device that requires a flow that gets an indication that the TSN path or the Detnet path is fully set up so you can start sending data over it. So that there was this idea that the UNI could actually signal, oh, it's up.
There are parameters already along those lines in the document for the flow, and this is very much in line what we have for TS and similar parameters. Like, do we, for example, if redundant parts are required, do we have those set up or not? Was it successful or not? Yeah. Okay. Thank you. We can move to the next one. Is
This is Xue Song, and I will represent other authors to introduce our work about the Detnet configuration in YAM model. Next page, please. I think you are familiar with this picture. This picture shows our scope of the Detnet configuration YAM model. And the YAM models are used between controllers and networks. It goes along with the Detnet flow information model just introduced. And our work covers three Detnet data models: topology data model, flow configuration data model, and the transport queues data models. Because the transport queues data models are still under discussion for the working group, so the current version of the draft, we only cover the first two data models. And next page, please. Okay. This slide show the what is defined in the Detnet topology data model. In the last version, there are only two groups of parameters, node attributes and link attributes. In this version of the draft, because the Detnet topology young data model is defined to augment to the IETF TE topology data model. So in order to go along with the design of the TE topology data model, we move some of the parameters of link attribute to the LTP attribute, which is the link termination point attribute, but the contents don't change. Next page, please. And here is the Detnet flow configuration YAM model. This YAM model is layer-based and row-based. We can see in the picture this one. The white flow is the client flow, and the blue flow is the Detnet service flow. And the service proxy can map the client flow to a Detnet service flow, and the Detnet service layer can do some service functions like replication, elimination, and ordering. And the transport layer can build up a Detnet tunnel between relay nodes or edge nodes. Next page. Thank you.
Just very slow.
Okay. Actually, this draft has just been adopted as an working group document. And during the polling, we collect a lot of comments from the mailing list or offline. So in the next version, we will do some updates. Here we list what will be updated in the next version. First is split the flow configuration into two models, MPLS flow configuration model and IP flow configuration model. These comments come from the authors of the data plan solution because the MPLS and IP data plan solution are different. And we also will end sequence number generation relative parameters. In this part, we will also take OAM into considerations, and these parameters are only for MPLS flow configuration model. And also, in this version, we have Detnet service encapsulation and transport tunnel encapsulation. In the next version, we will end the decapsulation part. Next page, please. Yeah, this slide shows the MPLS flow configuration model, and the parameters are used to configure the edge node. In the egress, we have to do the client flow identification, and we end the sequence number generation. The red block shows what is updated in the new, what will be updated in the new version, and the sequence number generation. And Detnet service function, service encapsulation, and the tunnel encapsulation. In the egress, we will do flow identification and service function and decapsulation. Next page. And this picture shows how we configure the relay node in the MPLS flow configuration. There comes a flow in the relay node. We have to identify the flow and do the service function and decapsulate the service layer and the transport tunnel. And we, in this example, we will replicate the flows into two different flows. They will go through different paths through the network. So they will do the encapsulation separately in the service layer and transport layer. This picture shows what will happen in the IP flow configuration, because there is no service layer in IP flow configuration. So the picture is much simpler than the MPLS, and we will not go into details about this one because it is similar. Yeah, and here are some open issues about the YAM model. Actually, we are going to define the transport queues configuration YAM model, but the issues here are there will be some overlaps or conflicts with IEEE if we define it without careful thoughts. First, I list the current work in IEEE about TSN queuing YAM models. They include per stream filtering and policing, scheduled traffic, frame preemption, and stream filter and stream gate. We can see that the YAM models defined in TSN IEEE are all about the some particular queuing algorithms. We are not sure whether these models can be used directly by Detnet to build up a Detnet transport tunnel with Detnet queues. Actually, there is a queues YAM model in IETF. This YAM model is based on the early RFC, which is the architecture of the DiffServ. Actually, Detnet is not a DiffServ or not only a DiffServ. So we just use the structure defined in this architecture, and also the YAM model listed below is also goes along with the architecture of the DiffServ. The picture shows the structure defined in this queues YAM model. There is classifier, there is meter, there is marker, and shaper and dropper. Actually, we can see that what has been done in IEEE TSN, the queuing model can be treated as kind of classifier or shaper or dropper in IETF. So what can we do in Detnet working group? What can we do about the Detnet transport queues YAM model in IETF? Perhaps we can augment to the IETF queues YAM model. There are some preliminary thoughts, but not included in this current version. Or we should leave it to IEEE. But the existing TSN queues models are separated in different YAM models. We have to figure out how to apply them to Detnet.
You have someone, you want to go now? Or
No,
later?
I'll wait.
Okay. One minor point I'd like to point out on the slide. You call out an individual draft. So there's opportunity to help them do the right thing and not call it QoS, call it DiffServ. Because as you point out, it's not a full QoS model, it's just a DiffServ model.
I'm not sure because there is no definition for Detnet whether Detnet queues belongs to the DiffServ.
But there's no definition of DiffServ as QoS. There's DiffServ as DiffServ.
Yes. But yes, actually it's okay.
This time it went fast.
Okay. Actually, this structure, I think it works for both DiffServ and
I'm not commenting on your draft. I was commenting on the individual draft here.
Yes.
You said there's work at the IETF, and I was just distinguishing between working group work and individual draft.
Yeah.
That's
okay. Okay. Thank you. Yeah. And what is the next step? Perhaps we can split the draft into two drafts. Actually, it doesn't matter to the authors whether split the draft or not, but we consider that the Detnet topology YAM is a relatively independent YAM model. So perhaps this part of work can be discussed in another working group to collect more useful comments from other guys. And the issue here is what can we do to define the Detnet transport queues? This is in or out of the scope of Detnet working group, and comments and contributes are welcome. Any questions?
Yes. Greg Mirsky, ZT. When you presented young model for Detnet flow over IP, you said it's much simpler than over MPLS data plane.
Yes, actually, I think all the parameters are needed for IP data plan solution has already been defined in this draft, but we have to split it into MPLS and IP.
Yeah, but don't really think that doing Detnet over IP data plane, we can say that it's simpler than over MPLS data plane.
Yes, actually, because the design of the IP data plane is still under working, right? So
Yes.
the YAM model will be updated based on the work of the data plane. So we will keep connect with the orders of the IP data plane design team.
Yes.
Yeah.
I agree with that.
Yeah, thank you.
Yeah, Mark Shen. I think the simpler is based on that assumption that the current MPS-based YAM model actually including MPS channel and IP channel. So based on that, the IP-based configuration should be has already included in the current MPS-based flow configuration. So we think that it's more maybe simpler to define the IP encapsulation model.
Yes, agree.
Christina, as we just discussed in the information model draft, if the time-based Detnet service are going to support in the information draft, is that means in the configuration model, we also need to add some time-related parameters.
I think the time-related parameters should be considered in the transport queues, right? Transport queues, YAM models.
So
Oh,
if
no,
we,
no, no,
it-
no.
I think that's a question right now that sits with the flow information document. If flow information gets scheduling, then yes, this document will get it. If it doesn't, then this document won't. So we have to first, this document is mirroring what we're doing in the other documents. So let's address it in that other document, and then this one will follow.
Yeah, agree.
I have a question. I don't see why is it difficult to use the yang defined by IEEE 2.1 for the IEEE 2.1 queuing?
Yeah, because perhaps we can go to the first slide. We can see the picture there.
Given the time, perhaps this is a good discussion point for Sunday.
Okay, let's park it.
Okay.
Just I don't make my point. I think the service for the industry would be to maximize the maximum set of reusing instead of duplicating and going off and doing different. But Sunday,
He's giving you a precursor, preview, that's the word, a preview of what we're going to say at the beginning of Sunday. So,
Okay.
one of the things that's really will be a good topic to sort out on Sunday is what work we do where, and make sure we're aligned and not unnecessarily duplicating work.
Yeah.
You had one question on your last slide. I wanted to get the feeling of the room. On the first point about splitting into two drafts, these drafts, these two models are pretty loosely related, and by having in the same document, it means they have to progress at the same time. By splitting, it allows them to progress independently and perhaps bring more people to work and focus on each independently. So from a chair standpoint, it's perfectly reasonable to split, but I'd like to hear from the room, they prefer to see split or continue together for the time being. So first I'm going to say, how many care about this topic? It's a reasonable number. How many think we should split? It's almost the same. How many object to a split? No one. So please split. When you do the split, we can go directly into working group documents. These shouldn't become individual. Propose some names, and we'll go with it. Thank you.
Actually, I want to add some answer to the question from the Janos.
Let's park it Sunday. We are over time.
Okay, fine, great.
Thank you for, yeah, it's definitely good stuff.
Yeah, that's great.
You like that?
Oh, sorry.
bit. We give preference to working group material. That was working group. So if you don't mind, try to cut by 5 minutes. So take 10 minutes if you can, rather than 15. Thank you. And sorry.
That's okay. I'm Juan Xiong from ZTE. My presentation today is the Detnet QoS policy and the Young model. And first let's do the recap of the IETF QoS related drafts. There are many drafts about the deep surf QoS, like the RFC 2475 and 2474. It is about the deep surf architecture and the IP DSCP field in IP header. And for MPLS networks, we have RFC 3270 and the TC field in MPLS header. And then we have many drafts about the per hop behavior and the service classes for the PHB, and just like the DF, CS, EF, and AF exact. And then the service classes, the PHB will be creamed in vendor-specific methods. Recently, the IETF QoS Young models has been proposed. There are 4 modules has been proposed, including policy, classifier, action, and the target. And then let's see the Detnet specific QoS requirements as per the Detnet architecture specified. The Detnet and low Detnet flows it exists with existing class of surface, and the Detnet flows must be differentiated from non-Detnet traffic. And the non-Detnet traffic cannot disrupt the Detnet flows, and the Detnet flows can be shaped and scheduled. And finally, the aggregation of Detnet flows must be supported, and more others, we can do more contribution. And then to meet the requirements, we propose to apply differentiated surface as it's deep surf for short. We propose to apply the deep surf model in Detnet and defined Detnet deep surf mechanism, including the Detnet IP and the MPLS encapsulation. For the details, we defined the Detnet classifiers. There are 2 classifiers types, the BA and the MF in the deep surf model. And the Detnet traffic conditional, we add a order action, and for the Detnet PHB service class, we add a DN service class for Detnet PHB, and we do a consideration about the Detnet cleaning, and we propose the related Detnet QoS Young model for this deep surf QoS model. And let's see the Detnet deep surf model. First, when the packets entering the end loads, the packets will be classified by the classifiers. There are 2 kinds of classifiers, BA and MF, and their packets will be classified and be metered, and it will be marked, shaped, dropped, order, or to the PHB, and to mapping to the PHB surface class, the PHB surface class has many kinds of surface class. We add a DN surface class for Detnet. And we propose the Detnet QoS Young model like this. First, there are many Detnet QoS policies. The deep surf QoS policy is just one of them. And then in the DeepServe policy, we have two kinds of the classifiers, the BA and the MF. And the BA, we classified the packets just using the DSCP in IP headers or traffic class in MPLS headers. And in MF classifiers, we will use the other information in the headers. For example, in IP, we will use the source and the destination address and the related information. And in MPLS encapsulation, we will use the S label for identify the Detnet flows. And then the traffic will be metered, marked, or ordered, dropped, and we add the order action for the Detnet to ordering the packets. So finally, we also do some considerations for the Detnet MPLS encapsulation. First, the S label can be used to classified in MPLS header, like the MPLS TC in the MF classifier. And the ELSP and LSP can be used to support the Detnet explicit rules in MPLS TELSP. And the order action can be used in POF, the package ordering function. And two or more SP can be merged into merged into LSP under egress SR to support the Detnet flows aggregation. More than two LSP carrying the same flow can be used to support the PRF and the PEF. The Detnet L2 surface is supported in TSN over MPLS scenario. The LSP ingressing over the engines can use the mapping from the PHB to the 802.1 mapping, and there are more others can be added into the consideration list. So last steps. We need to do more work and contributions, and welcome to join us, and the comments and discussion is welcome. Thank you.
Let's take a few comments. We definitely are running late, so we'll try to keep comments brief. I was expecting Norm to get up and David to get up, but
looks like Norm's decided to watch. This is David. So first of all, I want to say thank you for submitting these drafts. They actually raise what looks like a very important architectural issue for the working group to resolve. And I think the place where I start to explain the architectural issue is, should a PHB or multiple PHBs be defined for Detnet? If that is done, that then leads to the expectation that Detnet traffic will use Detnet specific DSCPs and will not use the existing ones.
Yeah.
I think that's a decision that deserves some attention and discussion. My grandfather, the philosopher, would be proud of the fact that I think I can argue both sides of this, so I'm not sure what the right answer is.
unfortunately we lost our mic right at the wrong time. From our standpoint, I think we're in agreement on this, is Detnet is about delivering specific service to specific flows. And so we're a little confused as to what a Detnet PHB per hop behavior really means.
Yeah, I've got Norman Finn. I've got a couple of questions, a couple of things I don't quite understand. As far as assigning specific DSCPs values, often in Detnet you will want more than one class of Detnet service.
you may have high speed and medium speed and low speed requirements. So you might need 2 or 3 DSCPs. Also, if you, on the other hand, you often, as Lou points out, you want to look at specific flows and give different flows different kinds of service. Interestingly, if you're using CQF, and I'll be talking about that later, if you'll be using CQF, you don't actually have to identify the flow at all. You can just use the DSCP or the layer 2 priority or whatever to assign it. But in several of these cases, especially if we're assigning specific code points for our exclusive use, then we kind of have to defend the network and defend against the entry of any frame with a DSCP that's using one of our code points, because it'll screw up what we're doing. Okay, if we have extraneous traffic, potentially it can screw up what we're doing, which implies a defense mechanism, which is not necessarily as important if you're looking at the particular individual flows and validating them. And if you're looking at the individual, if you're checking the flow ID before you give it Detnet service, then it's not a problem reusing DSCPs. So there are a lot of questions, and the part that I don't understand is when we talk about creating a PH per hop behavior. I'm not sure how I do that or what it means, so I'd ask someone else to help me there.
Given where we are on time, I think the right thing to do for this document is let's keep it around and think about it more and maybe talk about it more, hopefully on list. I should have started, before I said that, I should have asked the working group if there was interest in hearing more. So just, who would like to hear more about this topic in the future? Just to keep discussing it. It's a reasonable number, so I think the working group supports where I was going, but it's always good to ask the working group, make sure the chairs are in sync. So let's take the list and keep talking about it and think where it goes. You've given us some new things to think about, and because they're new, we're not quite sure what to do with them. Yeah, thank you.
Thank you. Discussion offline or in the mailing list is welcome, and welcome to join us. Thank you.
Thank you.
Yeah, this is David. Want to echo Lou's comments. Thank you. Thank you for raising this. The high-level answer to Norm's question might be to figure out how to define a PHP that is specifically fuzzy, and no, I don't know how to do that yet.
We really are running late, so it would be good to, I'd like to ask the next few presenters to go as quickly as they can.
Okay, so update to their information that been presented remotely at Montreal meeting, and welcome Mac Chen as an co-author, and we moved from the problem statement to proposed solution. The problem was that active OEM should be fade sharing with the data. For Detnet, with the use of packet replication elimination function, it presents a problem because pseudo-wire encapsulation does not have a space for the sequence number. And for the Detnet, their Detnet control word proposed with the use of sequence numbers. So thus, there were presented in first version scenarios that demonstrate that active OEM using pseudo-wire OEM encapsulation would not follow all paths or will result in a multiplication of OEM packets. So this is a proposed Detnet control word format, and that's how packet replication elimination functions can operate. Just a very simple example. So what we propose is here. their ACH associated channel header in Detnet encapsulation. The first nibble is 0001, while their Detnet control word has a first nibble of zeros. And we follow their ACH encapsulation, ACH format with a version and a channel type fields, but the reserved fields we define as a sequence number space for active OEM in Detnet. So that allows the elimination function to remove replicated packets after the first packet was processed. And using this, we see now that active OEM packets will behave normally as required, following all paths in the Detnet domain and receiving the same treatment when sharing the same MPLS encapsulation and S label. So the next step is that we'll be looking forward for definition of IP encapsulation for Detnet. Welcome comments, questions, and would like to consider working group adoption.
So Stuart, I'm sort of a bit worried about the fate sharing here, because I can see you fate share your OEM with the end-to-end service, but you don't necessarily fate share over the particular path that any given packet was taking.
Okay.
So there's a bit of a dilemma here. I don't quite get my head around it.
Okay, if the network doesn't use payload for determining behavior of the packet, then there will be a sharing. For example, so if they have ACMP and use payload to do hashing, selecting the path, then yes, of course.
Well, that won't happen. That won't happen because of the control word.
Right, but if they will use entropy label, then
Yes.
OEM will use the same entropy label, and then there will be a fate sharing.
Well, that's sort of true, right? So you go.
So we are really
Okay.
over time, and this sounds like a great list discussion.
I think it sounds like a working meeting discussion, actually. I think it needs
what?
It sounds more like a working meeting discussion, actually.
Sure.
I think it probably needs a bit more bandwidth than we get on mail.
We can certainly, yeah, if it's warranted to have an OEM interim or call, we're certainly open to it. So one of the questions we have is, do you see impact now because of OEM on the base data plane document?
No. Again, I believe that OEM can be a standalone document and doesn't have to be part of their base document.
But do you see any need to any change in any of the data plane documents to
no,
support OEM?
No.
Good. Just wanted to clarify.
No, as you see, we don't have any redefinition for the base protocol. We just define informational field that can be used in ACH, in the Detnet ACH format to do replication and elimination.
Okay, thank you.
I think without that conversation, I wouldn't be quite so certain. I'm just a bit worried that there are characteristics that we might need to measure that we can't measure, particularly as not all packets go on the same path depending on arrival times and competing traffic.
I don't want to start any discussion, but Pascal Tuber again.
Name, Pascal.
Pascal Tuber again.
Oh, I didn't.
Sorry. I just want to point out that there's work which started here, which is now at Beer, but which actually changes the headers to provide exactly what Stuart is mentioning, which is the capability to explore out of the replicated and eliminated path, which one actually worked. And control, when you have this capability, whether you actually replicate over all the ports, over all the possibilities. So this work exists, impacts this operation. I think if we have this interim, I'd be glad to discuss and explain exactly how it works. But you can't say now that OAM will not impact the signaling because it depends on which proposal we use and what we do.
All right, so
I do that exactly in this.
please no
class, but
discussions away from the mic.
we-
Or if you're going to have discussions away from the mic, take it quietly in the back or outside.
Sorry.
We'd like to move, we're really tight on time. Is it
Yeah.
necessary or can you take it up to the list?
Right, well, while you're changing speakers, I was only going to say you might have to turn off elimination to make this work properly.
Okay, is this a topic that the working group would like to work on? OAM, do they think it's important? How many people think it's important? It's a reasonable number. How many people have read this document? It is just slightly less. How many think that we should adopt this work as the foundation for the working group's activity on OAM? Should we adopt this document? It's just a few okay, it's just it's an okay number, not great. How many think we should wait until it matures? How many think we should not adopt? We have one. All right, so we will, the chairs will talk a little bit about it and think about where we go next. And again, anything you do to speed us up, I appreciate it.
Okay. So, hello everyone, it's Mark. I'm going to present this OM. It's also our own draft. So it's about how to do performance measurement on Detnet services.
It's not moving? You're backwards. Yeah, there you go.
Okay. Okay. Here's motivation. So as we know, Detnet is defined to provide an end-to-end boundary latency for and extremely low packet loss for critical flows. So it's very important to measure the packet loss and packet loss and packet delay in order to evaluate whether the SRA can be satisfied for the Detnet services. So, and at the same time, its metrics are also used for in the network traffic planning and troubleshooting and other performance evaluation. So, and at the same time that we know actually current performance measurement define active, passive, and hybrid measurement. And we think that passive measurement is more suitable for Detnet services because the passive measurement will not affect the behavior of the real Detnet services, and it can provide accurate results. So this document tried to define product extensions to support passive measurement on Detnet services. So the idea is straightforward. As we know, the current MPLS-based encapsulation introduced the service layer. It defined a new Detnet controller based on that field to support performance measurement. So for the loss measurement, actually for loss measurement, there's two conditions that to be satisfied. The first one is to count which packets belong to which flow. And second one is how to correlate the counts collected from the ingress and egress, and then to compare how many packets get lost, how many packets get transmitted. Then we can calculate how many packets get lost for specific paths. So the idea is very straightforward. Here we use the sequence number as a correlation identifier. The method is that we use the interval number. That interval number is calculated as a module of the sequence number and the pre-configured constant. Then at the ingress and egress, if they have the same measurement interval, then those counts belong to the same measurement interval. Then we can compare the counts and timestamps, hence to calculate the packet delay and the packet loss. Here's the delay, a similar idea. We just directly use the sequence number to correlate timestamp collected from the ingress and egress. And here is about how to indicate whether packet loss and packet delay should be enabled. Actually, we consider two solutions. The first one, we want to borrow some bits from the sequence number to indicate whether packet delay and packet loss should be enabled. Here you can see that there are two bits, loss bit and delay bits. And the alternative way is to use other, for example, the configuration model or PCE extensions and other way that can be used to enable or to indicate whether packet loss or packet delay should be enabled. But that way, we take more time and use more complex way to determine whether a packet should be counted or whether a timestamp should be stamped. And here's the math from Lu on the sequence number space.
Did you find an error in my math? I believe it.
Yeah, I just sent this to the mailing list when we discussing the sequence number space. So here you can see that given the packet size of 1.5 key and 26 bits, it seems sufficient for to allow offloads list here to hold 1 second. And also, here I just want to get the opinion from working group to whether can we squeeze out 1 or 2 bits for this purpose.
Okay. May I? Greg Mirsky, ZT. 2 notes, one being pedantic, that according to RFC 7799, this is a hybrid method. Okay, but
yeah.
Okay. Second is it looks very much like alternate marking method, and since this is an alternate marking method, which is RFC 8381, it not necessarily has to use 2 bits. With a compressed alternate marking method, quality delay measurement and loss measurement can be achieved with 1 bit flag.
Actually, here we don't necessarily to use that alternative marking-based solution because in with the Detnet encapsulation, it already introduced the Detnet control word. It has a sequence number. That information can be used to correlate the information. But don't necessarily to use other bits to marking packets and separate them to different blocks. We have already enough information to support
Maybe
that.
we should let him finish his presentation so you see what he's proposing and then go continue that discussion.
Yeah, and here's some news, just some extensions, 3 word extensions. We define some new TRVs to RC 6374 and 3 TRVs defined. You can see that you can look the details in the draft. And yes, I think today we just want to discuss this. I think it's a major point we want to discuss and get opinion from the working group.
Okay. Given how much time we have, we're going to cut the line and try to keep the comments short.
Okay, Stuart.
Cut the line with who's in line. I'm not Greg. You can stay in line.
So, Stuart, I think there's a bug here. So, using the sequence number works if you have a continuous expected rate of ingress packets. But if you have packets that you want to have Detnet treatment to, but you can't be sure when when the next one is going to arrive, in other words, it may miss elements out. I don't think you can do it with the sequence number because you have to sort of set the expected sequence number, but you may not have any packets coming, or you may get too many. So I don't think you can do it. I think you can steal a bit like you're doing here to do it, but I think using the sequence number for alt mark doesn't work unless you can be sure that you've got a constant flow of packets.
Okay, yeah, some comments.
That's a good discussion for the list, so look forward to the response there.
Al Morton, 2 comments. What Greg said, and 2, what a long sequence number you have. Consider at least detecting packet reordering. Thanks.
Okay. All right, thank you. We're going to move to the next.
Yeah. I will attempt to get us back on something approaching a schedule. We have a bounded latency. Does this work?
Is it not? Flip around. Pardon? Flip it around. Right. Maybe it's out of butter, but you can try it.
Okay. There we go. The changes from 1 to, we list the changes from 1 to 2. We worked on the document. We worked on the introduction. We replaced a bunch of stuff that described the 802.1 queuing mechanism. We just threw that out. It really wasn't that important, and we coalesced a couple of other diagrams. So I think the whole thing is clearer now with the diagrams. We added the next to last bullet. We've added more mathematical descriptions of in-serve queuing. And in particular, we added a new section 8 to describe the time-based queuing techniques that are not at all like the continuous int-serve sorts of leaky bucket credit-based queues. And I think that's a significant addition to the document. Now, what we discovered in some discussions, now that we're here face to face, is that there is a basic, it's easy to get confused when reading the current document. And the reason is that there are really 2 different kinds of problems to be solved when calculating worst case latency and the number of buffers you need to achieve 0 congestion loss. I'm calling them for the moment the static problem and the dynamic problem. The static problem is I know all of the flows that I need to accommodate. I know where they go, and I know what their requirements are, and I know what the characteristics are. I can perform a calculation that will tell me what the worst case latency is for every one of those flows and exactly how many buffers I need to ensure 0 congestion loss. And I can apply that calculation to a number of queuing technologies. It is possible to do that even with strict priority in some cases. Okay, there's a lot of things you can do with that. It's a very complex problem. It is not a polynomial problem. It may be, depending on your queuing technologies and so on, it may be insoluble in certain cases. But since you're doing this before you deploy the system, and since you know all of the flows, it's practical to do such a thing. The other problem I call the dynamic problem, and it's different. It says, given my basic configuration of the network, and I configure certain limitations in my network in more or less a static manner, then given one flow, only one Detnet flow, I can say this is the worst case latency that it can experience no matter what other reservations I make. That's the calculation you want to have in order to be able to have a system where I can add new flows. Because I know that I can add the new flows and I will not affect the other flows. Okay, I can add and delete flows as I go along. And This is much more restrictive as to what kinds of queuing mechanisms you can use. There are queuing mechanisms such that it's impossible to add a new flow without it affecting the other flows that are already there. Okay? There are other queuing mechanisms that allow me to do that. So, oops, went too far. Back up.
Hold on.
Thank you.
You want this one or the one behind?
Yeah,
Before it?
just back up one.
Okay.
Thank you. That's good. I'll take it from there.
Wait.
Okay. So, in the current document, latency O2, the static problem is assumed in the mathematical sections, like sections 5.2, 7.4, 7.5. Those are the sections that have all the math. They're assuming we're computing the static solution. A lot of the textual descriptions in the introduction in section 4.1 and 9.2, the description of the cyclic queuing model, are thinking about the dynamic problem. Okay? And that makes for a certain mismatch between those sections of the document, which make it hard to read. So you need to be aware of that if you look at the draft, or if you found it confusing, this might be why. And we are going to fix that in the next version. We then have, here's where I come to trying to get you back onto schedule. We then have a lot of descriptions of the queuing model and descriptions of how we can, about different kinds of queuing models, whether you're talking about per flow queuing or per class queuing. And we have a little bit of math. And I'm going to skip over that because it's too complex to go in the time we have to do it. And I'm going to get to Detnet time-based QoS because that's a significant new section. The first statement is probably wrong. Calculus use it, we have to modify it slightly, and we will and can. But basically, the packets are output according to some kind of repeating schedule. And two methods have been standardized so far in IEEE 802.1. The first is the cyclic queuing and forwarding, and the second is scheduled traffic. I'll talk about cyclic queuing and forwarding first. The idea is that you have two buffers on the port for this class of Detnet traffic. Everything I say is per class of traffic. You have two ports. The packets are flowing in from the left and going out to the right. At any one moment, one buffer is being used to receive data and the other buffer is being used to transmit data. At some point, a clock ticks with a regular time. And when that ticks, I switch which buffer is filling and which buffer is emptying. And it ticks, and I switch which buffer is filling and which buffer is empty. Now, I don't transmit a whole buffer's worth of data. I can't transmit 100%. I can only transmit some percentage of the data because I need time at the end of the cycle to receive it at the next hop. But using this scheme, the data progresses. All the data in the network goes click, one hop. Then the clock ticks, it goes click, one hop. Clock ticks again, everything in the network goes one further hop. So the end-to-end latency is trivial to compute. It's the cycle time times the number of hops. Admission control is trivial. Every flow is characterized by a maximum number of bit times it can take up in a buffer in one cycle. Maximum number of bit times per cycle. That's the definition of the limitation on the bandwidth. And admission is simply if the total, if all of the flows, I add up all their number of bits per cycle. If that exceeds the number of bits I'm allowed in the cycle, then I can't accept the new flow. If there is a long distance, a long delay from this hop to the next, then I can't do it with just two buffers. I wind up having three buffers where there is an offset in phase between a tick on the input side and the ticks on the output side. The ticks on the input side are in phase with the ticks on the last hop, modulo the distance the frames had, the packets had to travel to get it back in sync. So I tick on the input side, swap input buffers, tick on the output side to swap output buffers. Tick on the input side, swap input buffers, tick on the output side, swap output buffers, and so on. And now it works exactly the same way as the other one, except my margins are a little smaller because they don't have to accommodate line delay now. And everything spins 2 hops in every, spins 2 cycles in every relay because I have to keep the buffer separate. So the per hop delay is twice as long. But again, the calculations are trivial. The other cyclic queuing, so that explains cyclic queuing forwarding. There's the slide that says the words I just said. The time scheduling, every output queue has a gate that's controlled by a rotating schedule that has a precision of up to 1 nanosecond. And that's all there is to it. I've got these gates that control my output queues. This solution is different from the others in that the bandwidth of a queue, the bandwidth of my buffer resources can be multiplexed in time. I can have one flow use the gate, use the queue at this time, and then at another time, another flow can use this queue. That supports the non-continuous we have in the architecture. We talk about continuous flows, and I forget what the other term is, time flows, or, well, flows like video need the queuing mechanisms we've talked about before. Industrial automation, you often have a burst of traffic from this device, then a burst of traffic from this device, and it's all synchronized, so I can reuse the same resources, first for this kind of flow, then for that kind of flow. That's a different use. And so, yes, go ahead, ask your question.
I can ask.
Okay. So the time schedule queuing, the good news is that scheduling every transmission allows you to optimize everything. You can optimize latency, buffer space, jitter, interference with best effort traffic, any other QoS parameter you can name. Everything is available for optimization. The downside is, number one, at the present, the standard only supports 8 gates, 8 timed queues, not 1 per flow for 1,000 flows. And also, computing a schedule for a network is typically an incomplete process. Now, that doesn't mean you can't solve it. There are certainly solutions out there in use today, but it's not a trivial problem. And so this is my last slide, which is I would like this to become an adopted document. I would like this to become the definition of, okay, here's how you do, here's how you achieve bounded latency and 0 congestion loss. That's where it's going. I would love to hear suggestions about, Norm, get out of here, or yeah, this is a good idea. Here are some things you can do that will help you.
This is Xue Song, and some comment. I think this presentation from Norm can answer the question of David just now. David said whether Detnet will change the per hop behavior, right? If I get this right. I think Norm's presentation shows that the answer is yes, because I think this set of queuing algorithm is actually change the elements of the per hop behavior. I think including the classifier and the queuing and the metering and the dropper, perhaps part of them. But I think this is actually the per hop behavior for Detnet. If I think this is my point of view.
Yeah, and when I'm going to study it more, I suspect that Detnet involves several different per hop behaviors.
Thank you for the comment. I suggest to keep the pair behavior discussion offline. I mean, on the list or so on, we have time problem.
Sure.
Thanks for bringing it up.
So you've done a change here from where we left off at the last meeting, and from a process standpoint, you're suggesting that it's become normative versus informative.
Yes, that's my suggestion.
So what we talked about last time is that if we wanted to specify queuing behavior, that actually isn't something that we would expect to do in this working group, and that queuing behavior really belongs elsewhere. And we can talk about which working group. I thought we reached the conclusion that the group thought it would be valuable to have this information here, but merely to help inform people on possible implementation approaches versus being required. So if it's normative, it's required. And I think what we want to require is that we, per flow, give the service that is provisioned for the Detnet service.
Okay.
I don't think we want to require how a implementation delivers that service internally. And that's where we were at the last meeting, as I understood it.
Okay. I may. We need to talk more about this, obviously. What I would be looking for here is not necessarily this is the only way to do it, as much as these are the requirements for anything you do to produce a Detnet to boost the Detnet quality of service.
So you want to define behavior through a mechanism, but other mechanisms would be allowed.
Exactly.
Okay. So for us, I think that translates to this being an informative document, and that the requirement to deliver the service is what we specify. And that,
thank you. That was my confusion.
And that goes into the data plane. Hopefully I was clear, but that goes into the data plane solution documents. And that we certainly could point to this document as informational, but it wouldn't make it a normative document. We have a couple of comments.
So, Stuart, I don't understand the point you're making, Lou. This could be a standards track document, but it's only required behavior when you're executing the behavior of that document. It doesn't. The fact that it's not informational, that it's standards track, doesn't mean it in any way bounds Detnet to do it.
The title of this, the context is bounded latency. So it says if you're going to deliver bounded latency Detnet service, you do it this one way. And I don't think we want to limit our vendors to say that they have to deliver it this way. That's not something we typically do.
I completely agree with you, but that doesn't mean that this has to be an informational document. It can be a standards track document. It's just that it becomes the required behavior when you configure a piece of equipment to behave like this. It does just.
And I don't think that's in our interest to say that if you want to deliver bounded behavior, you have to do it this way.
No, I'm not saying that. We're not saying that at all.
Okay.
If I may, the intention was to give a range of choices, saying these are not all of the choices, but if you want to use this mechanism, here's exactly how you have to do it. Otherwise, it doesn't work.
Now, I think it would be cleaner if it was an informational document.
It may be fine if it's informational. It's not clear to me. I think putting it's exactly the same information, whether you're using IP in caps or MPLS in caps or some other in caps. So I'd hate to put it in one of those, in each of those documents, the same thing.
Okay, we're going to ask the working group a couple of questions, but I see our area director coming to the mic. If our area director wants to speak, Deborah, are you coming to the mic?
I'd love to hear.
I guess not. All right, David? That's David Black.
Norm, trying to understand what you're proposing. Is what you've referred to as the calculus part of the definition of bounded latency Detnet service?
Good question. I don't think it is. I think it's information about here's how you can calculate it, not necessarily here's how you must calculate it.
And in particular, it sound let me stick some words in your mouth and see whether you like them or you spit them out. It sounds like what you just said implies that the calculus is implementation dependent, and different implementations can meet the service definition in a way that requires different calculus to figure out service characteristics and admission control.
All right, we've hit the limit that we can go on this topic. So a couple of questions. How many people are interested?
And for those on the phone, my question sent Norm compute bound, so we're not sure.
So how many people are interested in this work? You have, I mean, that looks to me like the most of the room, or certainly over half, so that's a really good number. How many people think that this work is headed in the right direction if we ignore whether it's standards track or informational? So that's a reasonable number. It's probably about half of what was there before. I would like to take the discussion of informational and standard off the table right now. What we'll do is we'll work together with the authors, come back with what we propose to the working group, and see where we are from there. Once that we reach closure on standards track or informational, I think we'll move towards adoption.
Okay, good. Good. We will generate another version that makes this difference between dynamic and static very clear, and so it's better about what we're talking about.
We should move to the next speaker.
Looking forward to more input.
Thank you, Norm.
No, next presentation.
All of the people in one possible? Yeah, I'm one of the authors.
Of what?
Of the bounded latency.
We're off the topic.
Okay.
So you have 5 minutes.
Okay, hello everyone, I'm Christina. We are going...
I'm sorry, in the interest of time, think about where we left off at the last meeting and how we're moving from there. Sorry. Remember, we left the last meeting with a couple of questions.
Mm-hmm.
So really just talk about what has changed since the last meeting.
Oh, okay. This presentation are not going to introduce our proposal. Is want to discuss some problem with the people inside this room. We are going to implement the Detnet service and testing on real hardware routers. So we are facing with some problem. Yes, this is our objective. We want to achieve the packet delivery, the end-to-end bounded data. So the TSN, the Detnet architecture draft tell us the TSN techniques could be used in Detnet. So we find that the TSN has two solutions, the QBV and the QCH. Compared with the QBV, the QCH is more scalable for large-scale network. Then we are going to implement the QCH in large-scale network. However, we found that the QCH needs some extension because the traditional QCH requires that the link propagation delay should be smaller than the length of the cycle. For long link propagation delay, we have two solutions. The first solution is we set the cycle to be a very big value. That means we will get a large end-to-end latency and a large end-to-end jitter, since these two parameters are directly related to the length of cycle. If the length of cycle is t, the jitter will be 2 times t. So in order to guarantee the performance, we have the second solution. That is the left figure, the right figure shows we make some extension that different node, each pair of nodes maintains a stable cycle mapping relationship. So like the example shows, if the node A sends out packet at cycle X, according to the mapping relationship, the cycle mapping relationship, the packet will be resent out by node B at cycle Y+1. So here is our extension. But in this extension, there is a problem. As this example shows, at a single cycle, like the cycle Y, it will receive packet from different cycle. The orange part means the packet sent out by the node A at cycle X. This part of package should be resent out at the cycle Y+1.
So you have 1 minute left.
Okay, so the blue part should be resent out by the cycle Y+2. That means when a packet arrives at the node, it has 3 possible behavior. The first one is in queue, receiving Q1, and the second one is in queue, receiving Q2, and the third behavior is DQ. That means we need to specify each packet's behaviors in order to provide bounded data. So we need some extension on the encapsulate draft. We found that in the MPLS
I suggest
network.
moving to your last slide.
Yes, this is the
Oh,
last
okay.
one.
Thanks.
No, not the last one. The last one is thank you. Yeah, so at the MPLS draft, we find that the T level could be used for the cycle identified carrying, but we still want to some suggestion on the preferred header element, like the TLV of SRv6 or TC of MPLS levels. Compared with the MPLS draft, we find that in IP draft, there are some parts may be missing because it only lists the 2 solutions. The first solution is the control plan. The second solution is rely on the MPLS and the TSN techniques. We are wondering, is there pure IP-based deterministic forwarding? So in IP network, maybe we can find some other place to carry the cycle identifier, like the IPv6 extension header or other place, maybe DSCP. I know that people dislike use the DSCP. Yeah, that's all. The last page you mentioned. Thank you. And then we have the prototype outside.
David Black, at the risk of introducing yet more confusion, let me quickly interject a comment from discussion Stuart and I had just before the meeting on the IP-based solution. Typical way to get more bits is to insert a UDP shim.
So does that mean we can carry the cycle identifier through the maybe UDP header and then
You'd put in a UDP and a shim header, and you can put whatever you like in the shim header.
Email, please.
that also means we maybe need some extension in current IP.
Mark, please. Next.
One quick comment.
No,
Should we
no,
consider?
no, we're out of time.
Okay.
Please take it to the list. So one of the things is we've heard nothing on this document since the last meeting. If you want to progress this, you have to have the discussion on the list. So please discuss, take your questions there, and we'll go. It'll help progress. Please.
Sure. Okay, I will give a quick presentation about this signal routing based bounding latency. Yeah. Okay, serious. I think motivation is very simple. We just want to, as presented by Norm, there's time-based scheduling and other scheduling that can be used to achieve bounded latency. This draft is based on time-based scheduling and combine use the signal routing to provide bounded latency. So I want to skip this extra. This slide is just introduced by Norm in the previous presentation. So here's the idea. So I just want to mention one point here. The CQF assumed that a packet must be transmitted the packet must be received at one cycle and downstream, and it must be transmitted in the next cycle to ensure that the packet will be only stay at the most 2 cycles at a load, hence to guarantee that boundary latency. So this draft tried to improve on CQF by explicitly specifying the sending cycle at every load, and try to relieve the limitation that the sending and receive cycle has to be done in the same cycle. So in here, we call it cycle specified queuing and forwarding. The cycle used to which cycle is used to depend on the traffic planning and the path calculation, and the path calculation will consider the available cycle resources, bandwidth, and delay constraint, for example, the link delay and the processing delay. And here's how to use it and leverage the segment routing to do this. Here we can see that we define new segment, which is called cycle segment. Here it has 2 meanings. It used to be as only 1 meaning. That's the first one, to identify an interface, just like the adjacent segment. Here we extend it to include another meanings at the same time to identify a cycle of that interface. For example, the 1011 identify a cycle of interface 1 at node A. And so we can use this way. If you want to specify which interface and in which cycle a packet should be transmitted, you just need to attach a cycle segment to that packet. And by attaching a set of list to a packet, we can not only specify the explicit path, but also specify the sending cycle at each load along the path without maintaining any per flow states at intermediate load and the egress node. With this way, the boundary latency can be achieved. At the same time, it naturally supports flow aggregation. So here's a diagram how this solution works. So in order to, I think, in fact, the essential component of Detnet is traffic engineering. Currently, there's several protocols that can be used to do resource reservation. The first one is RCPTE, and also there are SRP defined in IEEE. But this kind of protocols will introduce per slow date at intermediate load. So CSQ is based on segment routing. So we just attach the cycle information and the resort information at the header. Hence there's no per flow state maintained in the intermediate load and the egress node. So it's very scalable to support large amount of flows. So in order to this, we need to some resource reservation. This is we call the virtual resource reservation. That is done by the controller. So this is we always want to solicit more review and comments and define. Also, if this the working group thinks there's a right direction, we want to define some SR extension in support of this cycle segment. And also we are consider how to use SR and non-time based QoS to support boundary latency.
Thank you for this. We'll have to work out where SR related work goes. We'd sort of expected to go to the spring working group, but we could talk about that as we progress it. You have one question. Is it something you can take to the list or no?
Okay, quick question. Did you do estimate on the scale of these new adjacency SIDs? Because if you do on each adjacency SID, ID per time slot, so would you have enough space in
This sounds like something we could take to the list. We are so out of time, we're actually into the next break. Thank you very much. We hope to see you on Sunday, and if not Sunday in Prague. Again, one of the things we really are going to try to focus on Sunday is figuring out the split of work of who does what and how we don't step on each other's toes. Some of what you're talking about might actually lead to work down in with 802 or 802.1, sorry. That'll hopefully we'll have some discussion on Sunday that clarifies that. So look forward to seeing you on Sunday and in Prague.
Thank you.
Thank you.